It's 11 o'clock. Again, good morning, bonjour, welcome, bienvenue everybody to the MuxLab game-changing ST2110 solutions. And thank you for being with us here today. We hope you'll have a great session and you will come out of it with some ideas that you can apply in your business. My name is Jose Mozota. I'm the president of Fremen Solutions. I'm a AV consultant for training. I hold a CTS and a CTSI certification. I'm an AVIXA trainer for CTS Prep, NetTech, and the networked AV system courses, as well as responsible for their AV over IP video training line that they just introduced. I'm also an HDBaseT authorized trainer and an SDVOE certified design partner. And I'm Dante certified to level 3. I'm really excited today to be here with you and to introduce the products that MuxLab has been bringing to the market to address the new reality of broadcast with the ST2110 solution. Our goals today is to discuss briefly AV over IP on a broadcast context. We're going to review what are the basic components of ST2110 to understand why the ST2110 becomes a game changer. We're going to give you an update on IPMX and NMOS, and we'll actually discuss what that is. And finally, we're going to present the solutions that MuxLab has developed to address the needs of customers that want to take advantage of ST2110. Please participate. Remember that there are no wrong questions. The only wrong question is the one that is not asked. If you see me looking to my left slightly, it's because I'm monitoring the chat screen that I have on a second monitor. And if I see a question that requires answering immediately, I will address it at that point. Otherwise, we'll address the questions at the end of the webinar. And we also have Joe Teixeira from MuxLab that will help us in case you have any product-specific questions. So what is our agenda for ST2110, a game changer? Like I said, why? Why do we even want to think about AV over IP in ProAV and in broadcast specifically? How have the AV over IP broadcast standards evolved over time? Why is ST2110 a game changer? What is NMOS? You see products like the MuxLab one saying, you know, we have NMOS 4, NMOS 5. So what is NMOS? Where is IPMX going? Do you know what IPMX is? If not, we'll talk about it. We're going to look at some application examples and then review the MuxLab ST2110 solutions. If you are in the AV over IP world, and you're actually in the broadcast world also, these are some of the industry alliances that you should be aware of, and I listed them in case some of them are not familiar to you. So you have the European Broadcast Union, the Joint Task Force for Network Media, the Video Services Forum, the Networked Media AMWA and AIMS, the Alliance for IP Media Solutions, obviously SMPTE, the Society of Motion Picture and Television Engineers, and then more on the ProAV side, the SDVOE Alliance, the AFNO Alliance for AVV, the Audio Engineering Society responsible for the excellent AES 67 IDEA, then AVIXA for structured cabling, Layer 1, AVIXA for AV, and something new, the SRT Alliance, which is something created called the Secure Reliable Transport. It was a proprietary solution that has become very interesting, and they have created an alliance around it, which is really to transport media over what they call dirty networks, referring to the internet where you don't have a lot of, let's say, confidence on what are you going to find when you send the signal into the cloud. And let's start first with a little bit of controversy. A lot of people say that AV is IT, and I beg to differ. AV is not IT, and IT is not AV. What people need to understand is that TCP/IP, it's a transport method for an AV signal. in the same way that we transport signals point to point with an HDMI cable, in the same way that we use the HT-T solution to transport signals. TCP/IP is another method to transport signals, and that's going to be even more clear when we start looking inside ST2110. Now, why do we want to do AV over IP? Well, as you well know, the traditional AV transport methods, even in broadcast, are all point-to-point. And essentially, we didn't have a lot of standards. So each solution has a name, doesn't play well with others. Sometimes to do things, you get into very complicated workflows in order to implement any ancillary data into your broadcast signals. Instead, when we're using a network is flexible and it's expandable. The system size of the whole AV over IP is limited only by the bandwidth that you have available. You can do virtual architectural rearrangement, which is one of the nicest things about using AV over IP. You don't need to physically go and change cables. You can do it virtually. AV over IP addresses not only point-to-point, but point-to-multipoint, the multicast, and multipoint to multipoint, which obviously are very useful in the ProAV, but also even more on the broadcast world. It is convenient and it's cost-effective because in many cases uses existing infrastructure or at least uses products that are available immediately. Typically on ProAV we use gigabit networks, and 10 gig are coming down on price. It can be centrally managed, so you don't have to be, again, in the place where the network is happening or where the things are happening for you to control it. And you can access content from anywhere. So once you actually have the signal on a network, bring your own device becomes a reality, because this is the age of mobility. Now, why particularly in broadcast? Well, in broadcast, one important thing is that if we're going to use something, we need something that is very reliable, that we know it works, and that we have the technical personnel available to actually help us implement that. Well, IP networks are ubiquitous, and infrastructure for IP networks is very well known. The IT resources and expertise are readily available. You can go and hire them off the street. There's a lot of people that know about IT. There's a universality of the IP infrastructure equipment, which allows you then to use any product off the shelf for your solution in most cases. And you have then a much larger component supply base. In some cases in broadcast, for specific applications, you have a limited number of suppliers. When you're going AV over IP or broadcast over IP, suddenly you open your supplier base to a much larger base. 10 gig and 25 networks, 25 gig networks are readily available, which are going to be required for the broadcast industry, since you're going to be sending signals that are not compressed in the production stage. And also look at the size. If you're using a Sirius 840, like call it matrix switcher or router or whatever you want to call it, it takes 31 units on the rack to have a 576 by 576. Instead, if you go for an IP solution like a Juniper or an Arista switch, then you can get 1,152 10 gig ports in only 13 units. So size becomes quite a factor when you're considering AV over IP in broadcast. And then now, with the arrival of ST2110 that we're going to discuss in more detail immediately, it enables new, smarter workflows that are increasing your efficiency big time. IP packets are much more flexible than an SID connection. So that allows you to think about things that you couldn't do before, and you can actually implement them. The other thing is, once we are on AV over IP, you have interoperability. So if you have a piece of equipment, a camera that is going to produce an IP-ready signal, for example, it can go directly into the switch. If you have a closed caption system that is working according to ST2110, it can go directly into the switch. So you can actually interoperate lots of equipment, which actually enables you to use consumer off-the-shelf products, reducing your costs. Now, there is going to be a cost to going AV over IP, and it's not going to be cheap to create the infrastructure to start, but overall, it's going to be cheaper than what you were doing before. AV over IP also makes scaling easier, and I don't mean a scaling of an image, scaling of the whole system is very easy to do with AV over IP by just adding ports or new switches to the system. It definitely reduces the cabling, simplifying deployments. Simply enough, when you're using now SDI, you also have an SDI timing network that you can get rid of, and there are much less cables to do a system over IP than do a system on a normal way. That's why AV over IP also becomes important for broadcast. And finally, ST2110 is really format agnostic, so it increases your infrastructure lifespan. So what ST110 will do to the signals that you are introducing into the network, it doesn't care how they come. It's going to break it into the right packets to be transported over IP. So how have the AV over IP broadcast standards evolved over time? Well, we used to have SDI, and essentially we had SDI 3G, and then we went to SDI 6G, SDI 12G, and that was working well for everybody. However, IP came into play, and the first thing we did was create the standard ST2110, and that gave us the ability to take the SDI signal and put it over an IP network. And we created a lot of things that we could do with that signal to make it behave in the way that we needed in broadcast. Then we introduced ST2110, and we're going to see what it is, but essentially we created elementary flows of all the components of the signal, and we also started using SMPTE ST2059 for the timing, which is obviously very important in broadcast. At the same time, AMWA and AIMS were developing the NMOS protocols, NMOS 4, ISO 4, ISO 5, ISO 6, that are giving us more control as to what we're doing. And we are really at the point today where we have a very complete, a very solid solution that has been in operation at least for 3-4 years already, and that people are adding bells and whistles to it when needs are identified, where things are not working as they should, or where people see the opportunity to actually modify even more the workflows to make them more efficient and effective. So it's a growing standard, things are added to it, and there's a lot of work groups that are actually trying to maintain it. So this is how an AV over IP solution has worked for broadcast. Typically, we have an audio-video signal, ancillary data, and timing that used to be together on the SDI cable, on the SDI connection. When we went to SMPTE 2022, we just put all those signals into one place. They were all, they continue to be together. They continue to be the audio with the video, with the ancillary and the timing, and it was just being transported over a network. The thing that SMPTE 2110 did that changed the ball game is that it actually separated the components of that signal into what they call essence streams. So now we have an audio essence, we have a video essence, we have an ancillary essence, and we have a timing essence. And I think that a lot of you in broadcast that are attending this webinar, maybe if you haven't worked with ST2110 or thought about it, can start to see the interesting idea of having those essences separated in packets that you can actually manipulate, transport, and then put together again so that you have your original signal. So with SMPTE 2022, it was a typical network. You would get something coming in, the video, audio, and data as a signal. It will be packetized, and it will be put into a network to get to the other side, where it would be depacketized and utilized. However, if in the middle you wanted to do anything to it, you wanted to actually work with audio processing, you needed to depacketize, you needed to de-embed, do the processing, embed again, packetize again, send it in. So the appliance that would do this would be complex. Also, if you wanted to do anything with ancillary signals, it will be the same thing. You will have to introduce them, remove them. So it was kind of complex to work with the streams or to take advantage of everything the stream had to offer you. Instead, with SMPTE with the Essence streams, as you can see, we have here audio, video, and data coming in separate, and then we packetize them separate. So they become packets in the network. And as you know, once you have packets in a network, each one of those packets is identifiable. We know exactly all the properties that it has. We know the stream that it belongs to if you're having some kind of AV transmission. So now you can actually intercept them and you can actually work with them and then repacketize them into a signal that you can utilize. So for example, here for the audio, you just need to pack and depack. You don't need to do the embedding, de-embedding, because it's already de-embedded. And these numbers here, 10, 20, 30, we're going to explain them immediately. So this is the suite of SMPTE2110 transport protocols as it stands today. There are more being developed. And you can go to SMPTE and download these standards. Normally they're fairly short, but they describe exactly how the system is supposed to work. We're going to look in details to some of them. So there is one that is the roadmap. It describes what 2110 is going to do. Then you have the 2110-10 that explains the system. It defines how the whole system works. Then number 20 looks at how to transport uncompressed video, which is what you want to do in broadcast. 21 takes into account that you want to look at the performance of transmitters. You don't want the switches to overflow the buffers and not being able to transport correctly. Later on, they started to develop 22, which is for compressed video, using VC2 or JPEG XS, because they realize there may be some compressed streams that you want to transport, and it's also a way to let ProAV get into SMPTE2110 by allowing the management of compressed video. Then they also had the 2110-20 streams put together on 2110-23, which is how are you going to use now streams that may be smaller, especially when you're doing compressed video, and take advantage of the whole bandwidth of the network. That was for the video. For the audio, they did the 30, which is how to transport uncompressed audio, and it does support AES67, which is very important. But they also look at 31 because there is audio out there that it's compressed. It's AES3 audio, non-PCM, and they also define how can you transport that if you have it. Then 40 look at how are you going to handle ancillary data. 50 actually look at how can you take a 2022-6 signal, so one of those signals that was not broken into different essences and still transported on the network. And finally, they implemented 2022-7 for redundant transport. I mean, what happens if we're missing packages? How are we going to make sure that we're still going to be able to assemble a complete signal and the other end? And for that, they implemented 2022-7. So this is what 2110-10 tells you about it. It tells you the system. It says that you're going to use UDP, that maximum you're going to have 1460 on the data payload, but you can also use jumbo frames, so it allows for the use of larger frames. It forces you to use the PTP precision time protocol of IEEE, and just be aware that then for broadcast, you're going to need switches that are PTP aware. Not all the switches are PTP aware. It uses RTP as a transport protocol, so UDP will work in layer 4. RTP will be the transport protocol handling the layer 5, layer 6 preparation of the stream, and the timestamps are tied to the media. So the timestamp for video would be with the video, the timestamp for the audio would be for the audio, etc. And they're going to use serial media clock offset. So when you start, everybody starts at the same point, and from that day on, all the timestamps are related to the initiation of the system. And very important, also requires the use of SDP as the session description protocol, which is very critical. And what that is, it tells the receiver how to interpret a stream. So when you're sending a stream, the receiver will get an SDP as per RFC 4566. And here it's an example. I know the words are very small, but look quickly here. It tells you that it's a YCBCR 422. It tells you that it's 1280 by 720. So it tells you where is it coming from, what stream it belongs to. So it gives all the information to the receiver to understand how to handle the stream that is going to come by using a standardized session description protocol. When you start now with the uncompressed video, one important thing that people should be aware of, that 2110 will only send video, is getting rid of the blanking. We don't need blanking. So we only send the video, and that also means bandwidth savings, because it saves, we'll see in the next slide, quite an amount of bandwidth by not sending blanking. What it does, it defines like a P group, a group of pixels, almost similar to what they do in compression with groups of images. And those P groups are then put with an RTP payload header that is specific for 2110-20. So this would be your standard header, and here we have timestamp, the synchronization source, the sequence number, the way in which the image is being scanned, so it's a scan across the whole screen in terms of lines that will fit onto the groups of pixels. So the payload header identifies everything related to the use of RTP. It gets on UDP in order that we can transport it without having the overhead and the latency of TCP. Then it gets the IP header, and then it gets the MAC header, so we can put it on the network. So the main thing here is the P groups are defined for different resolutions, and we're sending only video, not blanking. So you can see here, without blanking, on 2022.6, we're still doing blanking. On 2110-20, we don't do blanking, and we can save between 16 and 40% of the bandwidth, depending on the resolution and the frame rate of the signals that we are handling, which is very interesting. Now, on 2110-30 for PCM audio, it allows many options. However, if you want to be AES 67 compatible, and you should be for most applications AES 67 compatible, then you have to use 48 kilohertz sampling and 24-bit depth for the bit depth of the sample. You can use audio channel grouping. It allows 3 different levels of receivers that behave in different ways. We're not going to go in detail into that. The packet size, in this case, there are no jumbo frames, just 1440. It doesn't need you to use a session initiation protocol. It will handle it through the 2110 system, and it uses fixed duration packages. You can change that duration, but common, it's about 1 millisecond. So you here have all the packages for audio. They're all the same size. Then they go on RTP, they go on UDP, they go on IP, they go into the MAC layer. Ancillary data, it's extracted from the vertical and the horizontal ancillary, so it takes information about captions, time codes, ad triggers, etc., and then puts them also into RTP packets. So below the typical RTP header of sequence number, timestamp, and synchronization source, it will give you the length of the ancillary data. It will give you information related to the ancillary data inside the package. It uses data identified words, data count words, and checksums to make sure that the transmission was correct. And in that way, it creates packages that only contain ancillary data. But realize then that you can actually introduce the packages later on in the system. You can actually introduce them in a production studio that may be remote, because it's just a package that at some point or another is going to be assembled with your signal. Then just to mention quickly 2 that are important of the ones that are not essence streams, because the essence streams are the video, the audio, the ancillary data, and the timing that's behind it. The precision time protocol is traffic shaping. So if they realize that with all these signals coming into a switch, the buffer could be overloaded. So they define the way that receivers and switches should work. And they use either network compatibility or a virtual receiver buffer. Those are two techniques that we're not going to go into detail, but they are the ways that they allow the buffer to work so that it doesn't get overfilled. And very important, the redundant transport that they implemented with 2022-7. What it does, it allows you route diversity, because you can put two routes for the signal. And let's say that from this route you lost the packet 101, so you take it from the other signal. Okay, so by having the packages arriving from two different routes, you have extra packages available that will allow you to fill the gaps in the packages that could have been lost for one reason or another. So that's another important implementation, and we will see towards the end that it is implemented in the ST2110 products that MuxLab has developed. Okay, then that's about AV over IP. Then you have the Joint Task Force for Network Media, and that task force is trying to work so that ProAV can benefit from broadcast and broadcast can benefit from ProAV. They have published two documents that are free on their website. The RA10 is the reference architecture of network media, and the other one is a system environment and device behaviors for 2110 media nodes. So that one describes how networks registration and connection management works. I suggest that you go to their site if you work in broadcast and become aware of these documents. And together with AIMS, they have created what is called the IPMX, okay? Which is a roadmap in which they are trying to bring together broadcast with ProAV. So they take AES67 for the audio over IP. They take ST2110 to create the essence streams that we discussed already. And then they see, what else do we need? Well, we need the ability to transport video that is compressed, because ProAV uses compressed video. So they introduce some compressions that they're going to work with. We also need how to discover, register, and manage connections in a way that is seamless on the network. So we're going to use NMOS 04, 05, and we're going to discuss that in more detail. We're going to use IPv4 addressing, but we're also going to prepare for IPv6. We're also going to implement in one way or another things that are more like related to ProAV, like HTCP, forward error correction, the ability to use RS-232, the edit information, display ID, etc. And finally, we need to also implement security. So this roadmap has been moving. We are at this point where IPMX keeps working at completing the work. I don't think it's ever going to finish. And they are creating what are called networked media open specifications. And for example, we'll see at the end the MuxLab ST2110 products implement the NMOS or networked media open specifications that AIMS has defined on the IPMX roadmap. So the networked media open specifications are a series of specifications that are open. They are free. You can go to their website and you can download them. The main ones that are being implemented right now are 4 and 5, and that one is about the discovery of the devices. So that will be similar to Bonjour or MDNS, all those mechanisms that we have used so that when something gets connected, everybody knows who the receiver is, who the transmitter is, and registration of those devices. Then 0.5 would be like the layer 5 session layer type protocol that will allow to handle the device connection managements. If you also need to control the network, then they have 0.6, which will do network control that in the case of broadcast will be different than the use of IGMP. And then you have other things that are related to the use in broadcast, like event tally, audio channel mapping, etc. And there's also some best current practices that they are introducing, including security implementation guidelines. So anybody working nowadays on broadcast with the move to broadcast over IP should be aware of all these specifications that are open and freely available to you. So what NMOS does for 04 and 05, it describes how the devices register, how do they share that registration point, and how they can query the register for information about other devices. It supports both central registers and peer-to-peer discovery. And 05 describes the media flow, how they can be set or removed between a sending and a receiving device, similar to a multicast, join, or snoop, independently of the actual protocol that is used to carry the flow. So these things are totally protocol independent. And 06, it covers how to discover the resources that are available in the network and how those resources can be authorized, secure, and monitored. So the broadcast controller knows about the network topology from the network controller, and it can create, modify, and delete flows, as well as unicast and multicast receivers. So it is a complete control system for the network working under a standardized approach by NMOS. And this pyramid is pretty interesting. It comes from the European Broadcast Union, EBU, and if you Google EBU 3371, you can download the white paper where you can see this pyramid in more detail. I suggest you do it, because what they are doing is they're trying to determine what do you need to have a system that will work with open standards and specifications. So in the media transport side, anything in green, we already have it, is widely available. So that will be SMPTE time monitoring by precision time, timing, PTP, operation control with IS04, IS05, IS06, configuration and monitoring. There are things that are being developed, and also in security, there are things that are being developed. So these things need to be implemented also in order for us to have a strong pyramid with a strong base, especially everything related to security. But it's a very interesting approach to describing the future of the work that is being done with broadcast over IP. Okay. But so that was a short introduction about ST2110. I hope you do realize that by creating those essence flows, you now have a different way of approaching production, a different way of approaching closed captioning, a different way of approaching audio processing, embedding, de-embedding, because each of those flows are available to you independently. And that is quite a feast, if you want to call it that way. So we're going to look now at how MuxLab is trying to approach the solutions that are going to be used to implement 2110 in existing customers. So, you know, what we're trying to do here with AV over IP is the ability to access and control any system from anywhere. We have unprecedented level of controls. And all the solutions can work seamlessly because they are all based on standards. And together we can achieve that. It doesn't matter what your vertical is. In this particular case, we're more focused on broadcast, but all these things are spilling into the other verticals. And some of the things we're learning here in broadcast can be used on ProAV. Some of the things in ProAV can and will be used in broadcast. So the main thing about any AV over IP system is that it's flexible and it's expandable, it's convenient, and it's cost effective. Remote management, it's incredible what you can do with these systems. Are easy to install. They're kind of plug and play. In most cases, you may have to program your switches, but definitely they are relatively easy to install. You have low latency solutions that provide you uncompressed abilities for 4K video, etc. So traditionally, MuxLab has had products for broadcast. We have always had splitters, capture cards, extenders, test equipment, displays, etc. And now with AV over IP, we are introducing our line of ST2110. And the line for ST2110 takes into account the reality. And the reality is that today out there, most of the cameras that are being used to generate the signals that we're going to utilize are either an SDI connection or an HDMI connection. So what we have done, what we have decided in our approach is to actually create gateway converters that will take the signal from the existing cameras, be it SDI 3G or 12G or being HDMI cameras, and convert them into an ST2110 signal, or let's say group of essences, because that's what ST2110 streams are called. They're called essences. And the first one that it's already available to you in the market is the HDMI 4K ST2110. So essentially, it can take any signal from HDMI 1.4 up to 4K 30. It's going to depend. If you have a 444 signal, you can do 8-bit. If you have a 422, you can do 10-bit. Remember, what we're talking about here is the actual bandwidth of the signal. And if we go from 444 to 422, we are reducing the signal enough that we can have the extra 2 bits on the color depth. It will do 720p, and it can handle HDCP 1.4 and 2.2. The output will be ST2110. So when you connect that box to a network, to a switch, what you're going to have coming off this box is a stream of packets that represent the different essences that we discussed. So there will be audio packets in there, there will be video packets, there will be ancillary packets, and there will be timing information that it's essentially inside the RTP timestamps. That is the one that allows you to put everything together. We have also implemented the ST2110-30 redundancy. So that will allow you up to 150 microsecond delay with no frame losses. So if anything is lost on one side of the network, you can go to the other side of the network and find the package and bring it together. And we're using a standard REST API management that people are familiar with and can program easily. We have also implemented NMOS 04 and 05, so we have discovery and registration, and we have also the connection management between the different devices in there. In a little bit more detail, the idea is to put these devices on a 10 gig network. That's why in the previous one we could do 444 8-bit, 422 10-bit, just to keep the signal below 10 gig. It has zero latency. We know that nothing is zero latency. But when we have less than 1 frame of latency, we refer to it as zero latency. And the boxes have 2 independent 10 gig media ports that will support multi-mode fiber. And once it supports multi-mode fiber, that allows you to extend the transmission of the signal up to 400 meters if you utilize OM4 fiber. There's also an independent 1 gig port for management using regular category cable. The ports obviously have different NICs, so they have their own MAC address, and they both, once they connect to the network, they will get their own IP address, and you can set them up statically, but each one of them, it's a completely separate network in itself, network connection, network node. It does allow RS-232 pass-through to control the end devices, which is something that we use a lot. And also has 2-channel audio insert and extract, so you can extract the audio. It's already packetized as audio, very easy to extract it, but if you want to insert it, it will allow you to insert audio, and it will create audio package with its timestamp, etc., so that you can then utilize the audio that you have inserted on the production side when you're going to put together the whole stream to be viewed. And it does support, like any networks, point to multi-point and multi-point to multi-point. Here you have an example of an application diagram. You have here 2 HDMI cameras, and these HDMI cameras can then be connected to the transmitters of the MuxLab ST2110 solution. In this transmitter is where the magic is going to happen. So we're going to create the essence streams, taking the audio and the video in there. And we're not showing the introduction of the ancillary information at any specific point. What I have shown here is that because this is a network and it is based on networking, then you can put any other equipment from any other manufacturer that fits other kind of uses that we don't necessarily do, like a Tektronix Prisma monitor for the network. We can do an Epic multi-viewer. We can have an EVS closed captioning system. We can connect the Selenium network processor. Our precision time protocol generator could be a Tektronix one. So all these things are from different manufacturers, but all of them are working on the 2110 environment. And that guarantees you the compatibility, the interoperability of all these products. So you can connect then a laptop to this switch to manage the units via the REST API, and you can connect then an output from one of the ports to a receiver, and that will take the signal and bring it back into the signal that you want. So it will bring it back into an HDMI signal, and you can put it into the video mixer. Here, for example, the output of the video mixer is into what is called a return channel. So we put it into a transmitter to put it back in the network, and then we can look at it with a receiver on a monitor near where we have the cameras. So if we are actually at a place where we have the cameras long distance separate from the mixing place, for example, we can be monitoring what the production is doing and maybe do suggestions, etc. Do the work that needs to be done to have an excellent broadcast, a good production. Or we can also see it on the other side on an HDMI monitor, so that we can actually see what is being transported and that everything is working correctly. But the key here is the interoperability of all these things and the ability of any IP solution to send the signal back and forth, because once it's inside the switch, it can go wherever you want it to go. Here you have also an example now by utilizing the fact that you have two fiber connections on each one of those transmitters. You can actually set up two networks then. You could have the network 1 and the network 2. That could be used under 2022-7 to give you the redundancy in order to bring in the packets that may have been lost in some cases. But it can also obviously give you the reliability for important transmissions of having a network working when the other one fails, for example. And in this case, we have indicated the management system can be using REST API or can be using NMOS, like we already said before. Now, that product was the first one to market. Coming soon, we're going to introduce the 3G and the 12G ones. They're both going to be similar. They're going to operate uncompressed, the 3G on a 10 gig network, zero latency, less than 1 frame, redundancy 22/7, REST API or IS04, IS05, and 2 network media ports, 10 gig on the 3G product with the independent console for management. And if you're coming to the 12G solution, then the only change is going to be the 2 × 25 gigabit media ports, because if you're going to be working with 12G streams, you're then going to need a 25 gigabit network. Luckily enough, it's funny that the 25 gigabit and the 50 gigabit networks, the cost per port of the switches, it's actually lower than that of a 100 gigabit switch for a data center, for example, because when 25 and 50 gigabit came out, specifically broadcast really like it, and also ISPs started to use them to aggregate streams, and that made the cost of those particular ports to go down significantly. So it is actually very, very good from an economic standpoint to be running 25 and 50 gigabit networks. And finally, I like to mention some products that are not related to 2110, but that are important. So if you're working with all these systems, you need some test equipment, so you can generate signals, or you can analyze the signal with our signal analyzer. And the one that I really love, I carry it around with me when I go to all my live shows, when that happened 2 years ago. for demonstration is the triple display. We have a dual one, but the triple is really nice. I use it when I teach AV over IP because I connect streams with different compression, so I can do an H.264, I can do a JPEG 2000, and I can do an SDVOE Blue River NT technology one, and show also the quality of the image and the latency of the transmission of the source in a screen that everybody can appreciate. So that's a fairly interesting piece of equipment that is rack mountable. So if you're going to be doing AV over IP, be it for ProAV, be it for broadcast, how do you go around implementing it? Well, the solutions out there are many. The systems are very reliable and trustworthy. The fact that a broadcast is using them should give ProAV also a lot of confidence. On this world of pandemic, all the broadcasters have rethought their workflows. You probably know that Fox Sport broadcast NASCAR from the first time without being there at the oval where they were racing. They just sent the cameras, and all the signals were sent by high-speed fiber links to a central production facility where they were doing the production instead of having to move people around during the pandemic. So if you can transmit NASCAR for network broadcast, I'm sure you can do anything you want. But it's important that you educate yourself, because there are many solutions, there are many options, there are many protocols that can be used. There's different quality of service level in the way people have implemented their solutions, and you need to understand these things. The other one is you need to cut through the noise. What I mean by cut through the noise is the 1 gig proponents are going to tell you that 10 gig is very difficult and very expensive. The 10 gig proponents are going to tell you that the 1 gig doesn't work. And none of them are telling you the whole story. They're just telling you their story. And you need to have the knowledge to actually cut through that noise and decide, what do I need? Because at the end of the day, it's all about the application. If your application fits a 1 gig, fine. If it fits a 10 gig, fine. If you're in broadcast, if it fits a 10 gig, fine. If you need a 25 gig, then go for it and do the 25 gigs. But remember, it's a team effort of AV and IT professionals. In the case of broadcast, the precision of the timing, the whole topology of the network, the way the signals are routed, the performance that you expect of the network also requires you to get people with very good IT knowledge. But at the end of the day, they understand IT, they don't understand your AV signal. You may not understand all the IT, but you understand the AV signal, and it becomes a team effort. Well, thank you very much for your time. I hope that this was informative for everybody. And if you need more information, then you can approach Joe or the sales team of MuxLab to get more information about their 2110 solutions.